Here we go. This is the fourth page of the Unit 5 test review for Trig. Um, these are all about the half angle identities. And these formulas, mm, they're a little bit more complicated, but we'll just go through and kind of explain them as we go. So I just went ahead and I went through, made all the triangles. I've done this, in every other video. We don't need to do it again. Um, So we have our quadrant 4, make the ratio. So we have cosine of A is adjacent over hypotenuse. Use your Pythagorean theorem to figure out that third side of the triangle. And keep in mind, since it is going down, it needs to be a -7. Similarly, over here, the adjacent side is going to the left, so that also needs to be a -10 there. All right, so that's always a good kind of first step here, is to just get all of your trig ratios, and then it's just going to be a matter of filling everything out. All right, so the cosine of a over 2, this identity here, is plus or minus the square root of, this one is 1 plus cosine of a all over 2. All right, so the big thing on this section here is that plus or minus thing. What does that mean? So one way to think about it, and this is kind of how I think about it, we're cutting an angle in half. So if you think back to your unit circle, we know everything in quadrant 4 is between 360 degrees and 270 degrees, right? All of these angles in here are somewhere between 270 and 360. All right. So what I would do is just pick any angle in there. I'll pick 300. 300 is more or less right there. Now take that 300 and cut it in half. All right, and that's 150. What we have to do is think about, where does 150-degree angle end up? 150-degree angle is over here. That is in quadrant 2. All right, so think back to, oh man, it might have been I think it was unit 2, where we were talking about the unit circle. We had this thing, we said all students take calculus. All right, if we have 150-degree angle, that's in the second quadrant. We know everything except for sine and cosecant are negative in this quadrant. So since we're looking for the cosine and it's in the second quadrant, we end up having a negative value here. All right, so we know when we just kind of write this out, we're going to have a negative value. So this ends up being -1 plus, and again, we know what the cosine of A is. The cosine of A is 24/25. So we're just going to write 24/25, and then all of that over 2. All right, and this is kind of our ratio here. So what I'm going to do now is, to simplify this, I'm just going to plug all of this into my calculator. All right, ignore the square root for now. We'll come back to that later. So go ahead, just like last time, just like we've been doing a bunch, make your fractions. 1 plus, throw another fraction in there if you want to. That's 24 on top, 25 on bottom. And then we have that all divided by 2. All right, that gives us 49/50. This equals negative square root of 49/50. All right. And if you want to think about that, that's negative square root of 49 over square root of 50. All right. Now, break down those radicals, simplify them if you can. The top turns into a -7, right? Square root of 49 is 7. And then on the bottom, we have 5 square root of 2. And then the last step here is to rationalize the denominator. So multiply the top and the bottom by that square root of 2. You have -7 square root of 2 all over 10. Right? And that is your final answer. That is the cosine of A over 2. All right. So now on the next one here, you have your tangent. So the identity for tangent is 1 minus, this is actually the most simple one, 1 minus cosine of A over the sine of A. There's no square root in this one, which is always nice. Right, so that's going to be 1 minus, we know the cosine of A is 24/25. So you get 24/25 all over, we need the sine of A. And the sine of A, -7/25. All right. And from there, if you want to throw that in your calculator again, you could do that. If you want to kind of do it by hand, the top turns into 25/25 minus 24/25 all over -7/25. But if you look at the top there, common denominators, so you have 1 over 25, and that is all over -7/25. 25's cancel, and you're left with 1 over -7. All right, and there you go. That is the tangent reduced down. And then the last one, your identity here. Let's get a different color. That is plus or minus again with the square root of 1 minus cosine of A divided by 2. Right. And again, this is a sine, and just kind of like the reason above, we know a sine is positive in quadrant 2, right? This idea here, sine is positive in quadrant 2. So we are going to end up sticking with the positive value on this guy. All right. So plugging in what we have, square root of 1 minus, the cosine ended up being 24/25 all over 2. All right. So it looks similar to the cosine identity, but it is different. You just have that minus sign in the middle is the only difference. So we end up with negative square root of, what does it give us? 1 over, I think it's 1 over 50. Yeah, okay. So that gives us negative square root of 1 over square root of 50, which gives us 1 over 5 square root of 2. It's negative, right? No, it's not. It's positive, sorry. So it's a positive. So that means that's a positive. That means I'm not going to write the plus sign. So we have 1 square root of 2 over 10. All right, and that is your sine of A over 2 reduced. All right, so that first problem is done here. So on to the next one now, just same idea. They give us the cotangent of x is -10/24, and it's in quadrant 2. So make sure your positives, your negatives are all good. Write out your 3 trig ratios and then just plug them in. All right, so the sine of x over 2, this one ends up being plus or minus square root of 1 minus cosine of x all over 2. And again, let's think about that. We are in quadrant 2 to start off with. All right, we know everything, every angle in here is between 90 degrees and 180 degrees. So pick an angle somewhere in there, doesn't matter. I'm going to pick 100. All right, so 100-degree angle is probably right here. And if we divide that by 2, we get 50. All right, so that tells us a 50-degree angle is in quadrant 1. All right, we know sine, cosine, and tangent are all positive in quadrant 1. right? So for all three of these, they're all going to be positive values, right? So let's just plug it all in, right? We have cosine of x. The cosine of x is negative 10/26. So this is the square root of 1 minus 10/26 all over 2. That gives us square root of 16/26 all over 2. Simplifying further, square root of, I'm going to call that, what do I want to call that? I'm going to call it 8/26. And that's a fraction we can reduce. It's 4/13. So this is the square root of 4 over the square root of 13. Right. And there we have it. So I did skip a few steps in there. So what I did is I reduced 8/26 is 4/13. Square root of 4, square root is 13. Square root of 4 is 2, and then I just rationalized the denominator. So I did skip a few steps in there, but that is your final answer for the sine of x over 2. Tangent of x over 2. This one, I'll see here. This is 1 minus, what is this identity? 1 minus cosine of theta, or in this case, cosine of x, all over the sine of x. That is 1 minus cosine was negative 10/26. And then the bottom was, what's the bottom here? The bottom is 24/26. So let's see here. That gives us 36/26 all over 24/26. 26's cancel. 36 over 24. All right, and that is a fraction we can reduce. That's probably like 1.5 or something. Yeah, so this is 3/2. All right. So there you go. That's your answer for the tangent of x over 2. And then the cosine of x over 2. This one, again, plus or minus, but we've kind of already established that it ends up being the positive value. So 1 plus your cosine of x all over 2 ends up being 1 plus the cosine value was negative 10/26 all over 2. We square that entire thing, whatever that gives us. We're going to have 26 minus 10 is 16. So we have 16/26 all over 2. I made a mistake. Shoot. I made a mistake on the first one. We'll fix it. This one gives us square root of 8/26, which is the square root of 4/13, which is 2 over the square root of 13, which is 2 square root of 13 over 13. All right. So there we go. That should be correct. I did make a mistake on this one. This should have been a minus sign here, which makes this the 36/26, which makes this an 18/26. So I need to erase this. This is no good. which gives us, let's just reduce that fraction. 9/13. Which is 3/square root of 13, which is 3/square root of 13/13. There we go. Yeah, so that is your answer for the sine of x. Sorry about that. But that should be good now. All right, so that is the first two. All right, let's just finish off. Let's finish strong here. Find the exact value using the half angle formulas. So we know, again, the sine of a/2 equals plus or minus the square root of 1 minus the cosine of a all over 2. All right, so keep in mind on a problem like this, that 195, that is your a/2. So a/2 equals 195. So that tells us a is just twice that value. 195 times 2 is 390. Right? So plugging that in here, we know the sine of 195 equals plus or minus the square root of 1 minus the sine, no, not minus the sine, minus the cosine of 390 all over 2. Right now, think back to your unit circle. A 390-degree angle does this. Figure out that coterminal side. This is a 390-degree angle. 390-degree angle, look for that reference angle, right? How far past 360 is it going? So this is a 30-degree angle. So instead of saying the cosine of 390, I'm going to say the cosine of 30. All right, so let me get rid of all this. Cosine of 30. So this equals plus or minus the square root of 1 minus the cosine of 30 all over 2. All right. This is in quadrant 1. We said everything in quadrant 1 is positive, so this is going to be a positive value. And it's the square root of 1 minus, what is the cosine of 390, or the cosine of 30? Well, let's go back to our unit circle. Cosine of 30 is the square root of 3 over 2. All right. So, what does that give us? Gives us the square root of, we're going to call this 2 minus the square root of 3 all over 2, and then all over another 2. So it gives us the square root of 2 minus square root of 3 over 4. And if we wanted to simplify that further, we're going to have the square root of 2 minus the square root of 3 over 2. All right. So you kind of have a square root inside of a square root here, and that looks kind of weird. And it says your answer to 19 should be the same as number 1, right? So let's see what we got on number 1. Number 1, we had square root of 2 minus square root of 6 over 4. Obviously, that's different. So let's see if that's the same decimal approximation. So we have That's not what I want. I want to make a fraction, I'll put y equals square root of 2 minus the square root of 6 over 4. All right, so there's that decimal, some negative number. So let's see what we got on this next one here. 2 minus, and then you get another square root of 3 on the inside here. And then divide that by 2. Hopefully this gives us the same decimal. All right, it does, but it's positive. And it should be positive because I think I made a mistake on question 1 now. This needs to be a positive number here. So I think we're good. All right, so this thing right here, this decimal approximation, whoa. All right, it looks different, but it ends up being the same decimal value. All right, so they do check out. All right. One more here, tangent of 15 a over 2 equals 15, so a equals 30. All right, so basically we have 1 minus the cosine of 30 all over the sine of 30. That gives us 1 minus the square root of 3 over 2, all divided by cosine of the sine of 30 is 1/2 from your unit circle. All right, plugging all of that in, we're going to have 2 minus the square root of 3 all over 2, and that whole thing is divided by 1/2. So you don't divide fractions, you multiply by the reciprocal. So basically, this 2 cancels out with that 1/2. And we're going to end up with 2 minus the square root of 3. Right? So that should be the same answer, which it is. We have 2 minus the square root of 3. So there's our 2 minus the square root of 3 as well. All right, so there we go. All the answers line up, and I don't think I made any more mistakes on this one. So this video is done.